In this video, we shall look at some basic rules of differentiation. Let's start with the first. If assume that y is a function of x and it has the following dependence, where n is a constant. So to differentiate y with respect to x, the result or the rule is pretty simple. The n goes in front, n, and the power of x will be reduced by 1. And that is the result for the differentiation. Let's apply this rule to some specific examples. Let's assume y is 1 over x. So 1 over x is quite simply x to the power minus 1. And we want to differentiate y with respect to x now. Following that rule, minus 1 gets to the front, so it's minus 1, and the power of x will be reduced by 1. So minus 1 minus 1. So the answer is minus x minus 2, or quite simply minus 1 over x power 2. The same can be done for this function, square root of x. Square root of x is quite simply x to the power half. So dy dx is quite simply bringing the half in front and reducing the power of original x by 1. You get half x minus half, which is 1 over 2 square root x in the denominator. What if y equals to 1? Now 1 is equivalent to x to the power 0. So dy dx equals, the 0 comes in front, 0, x, 0 minus 1, which is identically 0. That result that we have found previously is the same for any constant. Let's say 4. 4 can be written as 4 times x to the power 0. So the derivative of y with respect to x equals, you just write that 4. Now let's differentiate this, and we know it's 0x 0 minus 1. So the entire result is quite simply 0. So when y is any constant, its derivative with respect to, let's say, x is quite simply 0. The following rule is when y is a constant a, so a is a number, a constant that does not change, times a function, say, of x. So in this case, if you want to differentiate y with respect to x, it's quite simply the a follows du dx. I am purposely writing this bracket with x inside to show that this u is a function of x. If u is already known to be a function of x beforehand, so this bracket with x can be ignored, and that is the result. Let's look at an example of how to use this result. Let's say y is ax squared. Then its derivative, dy dx, is a dx squared dx, which we know how to compute. The 2 comes down, so that's 2, and the power of x reduced by 1, and that is quite simply x to the power 1, and the final answer is 2ax. Simple as that. Rule number 3. Let's assume y is given in terms of linear combination of the following 3 functions. U, which is a function of x, v, function of x, minus, let's say, w, a function of x. So of course that would automatically make y as a function of x. If you want to compute dy dx, or the derivative of y with respect to x, I will drop the bracket with x inside. It's quite simply du dx plus dv dx minus dw dx. A simple result. So let's apply that rule for this following particular problem. Let us assume that y is given by the following function. Y equals 2x power 3 minus 3 over x plus 4. And you want to determine dy dx. So you have to do the derivatives individually. First, let's do that function. So 2 will just follow. The 3 will get in front, so that's going to be 3. And its power will reduce by 1. So 3 minus 1 is 2. Now let's go to the second function, which is minus 3 over x. So minus 3 will just follow. Note that 1 over x is x to the power minus 1. So that minus 1 goes in front. So it's minus 1. And the power of x will be reduced by 1 into minus 2. Now the final term, which is just 4. The differentiating a constant is quite simply 0. So your final answer is 6x squared plus, because this minus and this minus will give you a plus number, 3 over x squared. This is a power with negative number, so x minus 2 is quite simply 1 over x squared. And that's the answer for this problem. Let's look at the following function. Y equals a constant a, x to the power n, where n is a constant, times b, which is a constant, plus x. And the whole thing is divided by c, where c is a constant. So n is a constant, a is a constant, b and c are constants. Before we find its derivative, let's expand the bracket. It will be a over c times b x to the power n. So that is the first term. And the second term is plus a over c x to the power n plus 1, because xn times x is xn plus 1. Now let's find its derivative. Let's differentiate this y with respect to x. Now note the first term, the two functions, function 1 and function 2. So the first function, this a times b over c are constants, so you can simply write them, ab over c. Now here you have x to the power n, so the n goes down, and the power of x is reduced by 1, so you get that. Now on to the second function. A over c is a constant, so you can write just that, and n plus 1 goes in front, so n plus 1 bracket, and the power of x is reduced by 1 into quite simply n. And that's pretty much a result. One other rule that we want to talk about here is the rule for dy dx. Now assume that y is a function of x, so dy dx is equivalent to the inverse of dx dy. So that's another rule that we need to know. Let's try to use this rule. Let's assume a function is given in the following form. X equals y plus 1 over y. And you want to find dy dx. Now, because the form of this function is such that it's easier to find dx dy instead of dy dx, and we can use that to find dy dx, we shall proceed to determine dx dy first. So dx dy equals d over dy of y plus d over dy of 1 over y. So we know derivative of y with respect to y is quite simply 1. Derivative of 1 over y with respect to y is minus y minus 2, according to the rules that we have discussed earlier, which can be rewritten as 1 minus 1 over y squared. And you can simplify it if you want to y squared minus 1. So this is dx dy. Now what we are interested in is dy dx. And from this rule, we know it's inverse of this result. So taking the inverse of that, you get y squared over y squared minus 1. And that's the final result. And let's now look at the following function. X equals to all that, and you want to determine dy dx. So let's break this function into pieces. So x equals to, the first term will be y squared, because y cubed over y is y squared. The second term is minus 3y over y. It's quite simply minus 3. And the last term is 1 over y. So let's determine dx dy. So dx dy for the first term is quite simply 2y, because that's what you get by differentiating y squared with respect to y. The second term is a constant, so it will not contribute. That's quite simply 0. The second term is 1 over y, or y minus y to the power minus 1, and its derivative will be minus 1 over y squared. So that's going to give you 2y minus 1 over y squared. You can simplify it a little. Y squared. So that's going to give you 2y cubed minus 1. Since we are interested in dy dx, which is the inverse of that result, it quite simply becomes y squared over 2y cubed minus 1. And that is the answer for this problem. As a final section, let's look at function of a function. How to differentiate a function of a function. Let's assume y is a function of u, and u is a function of x. So how do you get dy dx? This can be done with the following equation. dy dx is dy du times du dx. Because y is a function of u, it can be differentiated with respect to u, and since u is a function of x, it can be differentiated with respect to x. So as an example, if we set u to be x squared plus 1, and we ask what is dy dx. So using the rule that we have just outlined, dy dx is dy du times du dx. So dy du can be readily computed. It's 1 over 2 square root u. And du dx from this function, it's quite simply 2x from everything that we have discussed so far. So dy dx is a product of this and that, so it is quite simply 1 over 2 square root u times 2x. So the 2 will get cancelled. And replacing back the expression for u, which is x squared plus 1, we get the following as the final answer. Now let's assume you're given this function and you're asked to determine that derivative. So we can write the entire expression as y equals u to the power 4, with u being the terms in the bracket, 2x squared minus 3x plus 5. Now dy dx is dy du times du dx. Differentiation of y with respect to u is simple. It is quite simply 4u power 3. And this can be differentiated in a standard manner. The first term will give you 4x. The second term is minus 3. The third term is a constant, so 0. Substituting back the expression for u, you get 2x squared minus 3x plus 5 power 3 times 4x minus 3. And that is the final expression for dy dx. Thank you for watching.